Have you ever stopped to wonder how the internet just knows you? Well, that's what we're going to explore. Today, we're pulling back the curtain on one of the most important, yet totally invisible pieces of tech that powers our digital lives: the database.
I mean, really think about it for a second. When you log into your favorite app, it knows your name. When you add a song to a playlist, it's still there the next day. That shopping cart you left, it hasn't forgotten what you put in it. So how does all of that actually happen? Well, the answer is actually pretty simple. It all comes down to one thing: a database. You can think of it as the internet's memory. It's what turns the web from this forgetful, static thing into the dynamic, personal experience we use every single day.
And here's the really cool part. Databases aren't just some boring tech for giant corporations. They're the engine humming behind the scenes of the web as we know it. They are literally what makes it all work.
And yeah, when we say the web as we know it, we're definitely talking about the big ones. Think about the massive platforms you use every day. Social media, your email, they all have to rely on a super powerful, really well-organized way to store and pull up just enormous amounts of information in an instant. And that's all thanks to databases.
Now, to make this all feel a little less, abstract, let's use a simple metaphor. For the rest of this explainer, I just want you to picture a database as a big, exceptionally organized filing cabinet. Seriously, if you can hold on to that one idea, everything else is going to click into place, I promise. Okay, so you've got that filing cabinet in your head? Good, because with that image, we can break down pretty much any database into 4 core ideas. Once you get these 4, you'll basically have the keys to understanding how almost all data is stored.
So, first up, we have the database itself. This is the big picture, the whole shebang. In our analogy, it's the entire filing cabinet, the whole piece of furniture. It holds everything.
Now inside that cabinet, you have drawers, right? Each drawer is for a specific category of information. Maybe one is for users, another is for products. In the world of databases, we just call that drawer a table.
All right, so let's pull up in one of those drawers. Inside, you've got a bunch of individual folders. Each folder represents one single item, like one specific person's profile or one specific product. We call that single folder a row, or sometimes a record. And finally, on each of those folders, you've got labels on the tab that describe what's inside. A name, an email, a price. Those labels are the columns. They just tell you what each piece of information in the row actually is. Simple, right?
And this just brings it all together perfectly. You can see we have a table here called Publications. Each row is a single book. That's one folder in our cabinet. And the columns: author, title, type, and year. Those are just the labels on the folder, telling us exactly what info we'll find for each book. It really starts to make sense when you see it laid out like this.
Okay, so we've built this perfectly organized filing cabinet. But how do we actually find anything in it? How do you talk to it? Well, let's find out.
We use a special language called SQL. Now, don't let the word language intimidate you. It was designed from the ground up to be simple and to read a lot like plain English. It's way less like a complex programming language and more like giving a very specific, clear instruction to a librarian. You really don't need to be a coder to get the gist of this.
For instance, just look at this query. It's really just a structured way of asking, hey, can you select the title from the publications table, but only where the author is Charles Dickens? It's just a direct, crystal clear question.
And the database responds just as directly. It zips over to the right drawer, finds the folders that match your criteria, and gives you back only the information you asked for. It's pretty much a conversation. You ask a clear question, you get a precise answer right back.
But what about when things get a little messy? There's one more core idea that helps keep databases so organized and reliable. And it solves a really common problem. How do you tell 2 similar things apart?
Imagine for a second you just have a list of names, and you have 2 people on it named John Smith. Uh-oh, how do you know which is which? It could cause all sorts of mix-ups. The solution is to give every single row a unique identifier, or what we call a key. So now John Smith number 101 is completely distinct from John Smith number 103. Problem solved.
And that's where the primary key comes in. It's just a unique number or code for every single record. You see these all the time in the real world. Think of your student ID number. No one else at your school has that exact one. Or a book's ISBN number. This key guarantees that every single entry is unique and can be found with 0 confusion.
Now, I know this all might seem a bit theoretical, but the source material gives us this wonderful, practical way to start thinking about this in the real world. And honestly, it's way simpler than you might think.
And here's the best part. You don't start by writing code. You start by asking questions. What do I actually need to know? Which books did this customer buy? What's our most popular item? By figuring out the questions you want to ask first, you can then design a system that's perfectly built to give you the answers.
Because, ultimately, the most powerful and efficient databases aren't built on complicated code. They're built on a crystal-clear understanding of the information they need to manage. It's all about starting with simplicity and good planning, not with programming. And that brings us to this wonderful quote from Richard Feynman, which I think just sums it all up perfectly. That ability to see and convey the simplicity that underlies our complex world seems to me a rare and wonderful gift. The goal of a good database, and really any good explanation, isn't to add complexity, but to find the simple, elegant structure that was hiding there all along.
So, as we close out, here's a final thought to leave you with. Databases are just one example of an invisible structure that organizes our world. What other ones can you think of? Thanks for joining me on this little journey into the world of databases. I hope you found it as fascinating as I do.